This puzzle is called Bat Signal by Ambrose. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look. So the first rule is Fog of War, so obviously we can't see the whole board right now, or the whole grid. And as we enter correct digits, let's say this was a 3 and we type in the digit 3, then it would reveal all of these digits. You can reveal, if we somehow figured out that this was a 3, for example, it would reveal, out here. We don't have to just place inside the revealed areas. We could place wherever we, figure things out. Yeah, and obviously eventually we're going to fill in the whole grid, so we'll see everything. Then we have ratio, so black dots are digits that have a 2-to-1 ratio, so one of the two digits is double the other one. So if this was a 3, this would have to be a 6. If this was a 2, this could be a 1 or a 4, because obviously 1 times 2 is 2, 2 times 2 is 4. There we go. Then we have arrows. Digits, sorry, you got distracted. Digits on an arrow sum to the value in the attached circle. We don't see the circle, but there'll be a circle along this arrow somewhere. We don't know where. And all these digits will add up to that circle. But there could be more to the line. It could be something like this, and then have, can I do a circle? I don't know how to do this, but let's say there's a circle here. Oh, I don't know how I just did that, but I just did it. So this could look something like this, and then all of these would add up, all of the pink cells would add up to the green cell. Let's see. Oh yeah, all arrows have a single cell total, so we can't start getting multiple digits or like tens and stuff like that. The most they can add up to is 9. And the arrows do not branch. And different arrows do not overlap or cross. So that'll be good too. So like these are two separate arrows. This obviously the top one and this bottom one. It's not like they will connect, let's say right here, and then, do something like this and have two different things there, as far as I can tell at least. Yeah, so let's, I'll put a link down in the description if you want to give it a try. I think it's a 2 out of 5 difficulty according to Ambrose. So yeah, let's give it a try. Let me just plug in my phone actually, just make sure it's charged. Okay, yeah, let's give it a try. So the first thing I see, well, it's a kind of combination of things. So we have two different arrows here. The minimum we can put in these 5 cells are 1, 2, 3, 4, 5. And if we did that, we would have 15, which means these two arrows are both going to individually sum up to single cells. But they'll sum up to at least 15. But if we try to do 15 here, then how do we do this? How do we do this black dot here? Black dot needs at least one small digit on it. So at least one of 1, 2, 3, 4. You could have both 1 and 2 or 2 and 4, but it needs to have at least one of them. So we're going to have to, we can't even do this minimum, this initial minimum. We're going to have to get rid of one of the small digits off of the arrows and put it over here. So the highest little digit is 4, so we could switch this over to 4, 8, and then put the next smallest digit, 6, onto the arrows. And now we have, what do we have? 1, 2, 3 is 6, plus 5 is 11, plus 6 is 17. So currently we have 17 here. And these two would be 7 and 9. So, yeah, that means that these three, at a minimum, are going to add up to 17. Which is the most 2 cells can add up to if it's 8 and 9. If we put 8 and 9 here, as the bulbs, let me see if I can figure out how to do that again. If we put the arrows like this as the bulbs, this could work. But the thing that I'm thinking about is it possible to add one more digit in somehow? Like if this was like this. Could we do something like this, or do something like this, or like this? Because then they won't see each other, and then they can, like, in this case, or I don't even need to do it like this. Now there's, oh my gosh. Okay, like, right now they could both be 9s, and we would have 1 digit of leeway. Is this possible? Okay, well, let me just get rid of these lines for a second. So, at a minimum, let me think. At a minimum, these are going to add up to 8. Because these at most can add up to 9. So if these are... if I make this 8, that would make these add up to 9. How could we actually make 9? We can make this 1, 3, 5 and make this a 2, 6. But then this adds up to 9, and that breaks because we have this 7, 9 here. And if we maximize this side, it can't actually work. This side adds up to, how should I say this? This side adds up to 9. These 3 digits can't add up to 9. So if we take out the 3 and put in the 2, this adds up to 9. So I think this has to be a 9. Because we can't do another cell. We couldn't, like, scoot it over here, because minimum we could put in here is a 1, and this is a 10, and that's obviously too big. But we still... No, now we can't. So this is a 9, I think. I'm pretty sure this is a 9, yeah. Which then shows, I was going to say, and then this side over here couldn't bend because we can't... Even if we bend it once, we can't add 2 extra digits. We could only add 1 extra digit here, which would add it to, or which would make it add up to 9, which wouldn't work because we couldn't get away from this 9 far enough. Like, we couldn't get it over here or over here. So this is just going to be an 8, which makes this a 4 and this an 8. And that's a big arrow over here, and this is a different, not quite as big arrow. So let's say the bulb... What's the minimum we can put along this big line? Let's say this is the circle and this is the end. That doesn't really work. Okay, we'll just do it like this. So this could be 1, 2, and then this would be 1, 2, 3. That's 6 plus 3, that's 9, which will put a 9 here, so we have no digits of leeway. And this 9 would see that, so that doesn't work. What if we put the circle down here? Then again, we'd have 1, 2, and then 1, 2, 3. That's 6 plus 3 is 9, so this does work. I think this must be it. That's a 9. And we don't need that anymore. Oh my gosh. Okay. And then we have this 3 looking over, so this is a 3. This can't be a 3. And I'm drawing lines instead of erasing them. Okay. That makes, so we have a 1, 2 pair up here. It's 1, 2 as part of a triple up here, 1, 2 here, so these two are 1, 2. These are 5 and 6. Let me see. There's an 8 and a 9 up here. Okay, so there's an 8 and a 9 up here. Oh, that doesn't actually mean what I thought it was going to mean. Never mind. I was going to say at least one of 8 or 9 is going to be on this line. This can't be a 9, because you can't put a 9 along an arrow because you're going to add more digits to it, and then the bulb will be more than 9. Guess we have a 5 down here. What is it? So 5... Oh, this is... No, it's not 5, 6. This is 5... 4, 7? Yeah. And this is 4, 7, 8, 9? Yeah, this can't be a 9 still. I just said that. This is gonna be tricky. How can we make this work? Am I missing it? How can we make this work? I think we can add up... Yeah, this can't be the circle. Whoops. This can't be the circle. If we try to add either of these 2 digits up against each other, or with each other, this is at least 11 if we do 4 and 7, which doesn't work anyway because of that, 4, 7, but who really cares at that point? That's too big. So this can't be the bulb. I think this must be the bulb, which means this can't be a 4. But this could be... Yeah, this could be 7 plus 4 is 3. 8 plus 4... No, that wouldn't work. 8 plus 7 is 1. 9 plus... This could be 5. This could be a lot of different numbers. Oh, this couldn't be a 3, actually. It couldn't be 7 and 4 because of this right here. So 7 doesn't work either. Because 7 has to have a digit less than it, but it can't be 4. So this can't be a 7. Okay, that seems reasonable enough. Can we do something with this here? I guess we know this is the bulb, so this is a minimum of 3 and 4. Minimum. It doesn't have to be this. But okay, I think this does actually work. This is where we should have been looking. So this is minimum of 3, 4, which would be 7. So we have only one digit of leeway. We can't bump this up twice and make this a 9. Because obviously there's a 9 right next to it. So this could be 7 or 8. With 8, again, we can't use 1 or 2, so it must be 3, 5, which means this is either 3, 4 or 3, 5. And this digit can't be a 3, and it must have a 3, so this is a 3. We can't double 7, so this must be a 4. And this is a 2 or an 8. Now these can't be 4, so this can't be 5. Oh no, never mind. Oh no, this can't be a 2, right, this can't be a 2, this just must be an 8. Which makes this a 9, which doesn't really give us all that much information because we kind of already knew that line, didn't we? Okay. Oh, these can't be 4, so this is 3, 4, 6 over here. 9. 9, so one of these is a 9. One of those is a 9. 3, 3, one of these is a 3. Oh, this can't be a 9. And these two digits are the same. We can record that. Because whatever this digit is, whatever green is, this is going to be the opposite of green. So we can mark that as orange, let's say. So these two digits are going to be the opposite, and then these two digits are going to be the opposite, meaning these two, both green ones, are going to be the same. I don't know if that's helpful or not. Oh, I'm an idiot. There's an 8 right here. What am I doing? Oops, that's supposed to be an 8. What am I doing? Okay, this just must be a 4 to make 3 plus 4 is 7. This must be a 2, which is going to make this a 1 and a 2. This could be a 1. I guess we have 3 and 7 over here, and we have an 8 over here somewhere. Okay, and 2, no we don't. No, sorry, 2 is down here. Okay, so this is a minimum of 1. This is a minimum of 1 also. Okay, that's not really super helpful. 4 is also over here, actually. 4s and 8s are both forced into this. So this is a 4 or an 8. I think this could be like 1, 1, 2, strangely enough. So I don't think we can say that this isn't... Oh no, that does break the puzzle. That does break the puzzle. If we tried to make this a 4, at minimum this would be 1, 1, 2. At least that I see. This can be a 1, this can be a 1, and then this one can't be the repeated, or either of the 1s. So it must be a 2. Which looks like it works, but actually that makes this a 1 and this a 2, which then makes both of these 5. Because it was 1, 2, 5, it can't be a 2, can't be a 1, can't be a 1, can't be a 2. So both of these are 5, and that obviously doesn't work. So this can't be 4, so this is 8, and this is 4. What is this? This needs a 9, which must be here. What does this need? This needs 5, 6, and 9, and sorry, I'm now... Okay, 5, 6, 9 for this column. This can't be a 9, so this is a 9. Okay. I thought that would give us a little bit more, but I guess not. This could still be a 1, this could be a 1, this could be like a 3, I think. Which means we don't really know where the digits could... I don't think we have enough there. What's left here is 2, 5, 6, and 1. So this is 1, 5, or 6. There's a 9 up here, and this can't be a 9. I already marked that. 8 is down here somewhere. It is over here somewhere. 4 is in there somewhere. What am I missing here? This puzzle hasn't been too tough so far, so I'm thinking I'm missing something dumb like this 8 sitting right here. And apologies if you can hear my chair. Wasn't thinking and slightly moved, and it is the loudest chair in the world. This is a 1, 5, or 6? I guess this can't be a 6. That would make these two are a minimum of 1, 2, but again, 1, 2 doesn't work. So minimum of 1, 3. So that just makes this a 1. Yeah, I can go through that again. So this is a minimum of 1, 3. We looked at 1, 2, and that doesn't work because it makes pairs with this 1, 2, and then makes both of these 5. So 1, 3 adds to 4. If we make this a 5, that'd be 4 plus 5, which is bigger than 8. So that won't work. So 5 and 6 both don't work, means it's 1. Now we have this. So this could be... Oh, this can't be a 1 anymore. So this is 1, 2 over here. 5, 6, 9. And this is 3, 7, 5, and 6. Okay, well, let's look at this. Theoretically, those are the options for a black dot. But it can't be 4 because of the 4, and it can't be an 8 because 8 only goes with 4. And it can't be 1, 2. Because if this was 1, 2, it'd be the same situation as before of making this 1, 2, except just slightly different cells, but these 1, 2s would match up. And then both of these would have to be a 5. So this can't be a 1, 2, it is just a 3, 6. Okay, what makes that not a 3, makes that not a 6. Okay, this could still be a 1. This cannot be a 2. Again, we can't do 1, 2 like this. Can't be a 3. Could be a 4. We're getting closer to 8 as minimum, but not quite there yet. What is that? That's 6? We have a 3, 6 pair here. Is there something with that, maybe? I don't see it. Oh, no, okay. Where can we put... We need 3 and 6 in this column. We have a lot of cells we've already ruled 3 and 6 out of. Neither of these two can be 3 or 6 because we have a pair in the box. Obviously, this is going to be one of them, but we only have one other cell for the other. So this is a 3 or a 6. Do not know if that's helpful. What's left in this column? 1, 2, 5, and 7. Well, we can't put 7 here on the line, right? Yeah, because this would be a 1 plus 7, and then we would need another cell, which wouldn't work. So this would be 1, 2, 5. This is the 7. Okay. So what? So this can't be a 7. So these two need to add up to 9. And it can't be a 1. If this was a 1, whoops, if this was a 1, this would have to be 6 to add up to 7. We've already used the 6. So this is not 1. So this is a 2, 5 pair. Okay, that looks good to me. Oh, and this can't be a 2. We literally have a 2 right there. Apologies, my throat is getting a little scratchy. 1, 2. It's a 1, 5, 2. I think that's all good. So far, so good. We know that because the arrows don't cross or intersect or branch or anything, we know that this is just one line here, which is again a minimum of 3, 4, because we've already used 1 and 2, and this cell can't even be a 3 either. So this is minimum of 7, so it could be 7, 8, 9, but it can't actually be a 7 because we have a 7 right there. So it can't be that. Could it be 8? If it was 8, it would have to be 3, 5. Let me look at this. If this was an 8, it's hard to read that, so let me just remove that for a second. If this is an 8, this would have to be 1, 7, which it can't be, 2, 6, which it can't be, or 3, 5, which it also can't be because this cell can't be a 3 or a 5. So this is just a 9, which makes this a 5, this a 9, and a host of other things. Nice, okay. Okay, so this is not 1, 8, not 2, 7. It could be, oh, it can't be 3, 6 either because this cell can't be a 3 or a 6, so it must be 4, 5. Makes this a 4, this a 5. What are these? 3, 7, and 6? This is just a 7. Okay. And this is a 5, this is a 6, which I could have done earlier, but it doesn't really matter. And this is a 1, which goes here, and an 8. This is a 7 and a 9. What's left in the column is a 4 and a 7, goes here and here. Let's see, 5, 6, and 8, which I don't think we can reduce at all. Or, I mean, we can reduce a little, but we can't figure out any of the digits. Okay. So this is at least through 2 cells. We could have the bulb here, or it could go like this, or like this. Obviously not both, but it could do something like this, theoretically, and put a 9 here and do like, I don't know, 9, 1, 2, 6 or something. Come on, there we go. Whoops, not there. Right like that. Okay. What's left in here? This is 3, 6, 9, and it can't have we can't have a 9 midway along the line, so this is the 9. Okay, well, it's not the exact situation I talked about. Let's just type in the things that this can be, so we can see things a little bit clearer. 1, 2, 8, 7, 4, 3, 6. This can't be 3 because 3 has to be 1, 2. It could be 4 as 3, 1. This can't be an 8. So 4, 3, 1 works. 6 does not work. 7, 6, 1 does work. So this is always a 1. But I think either of these work. One of these is a 2. We haven't put a 2 in this column yet. And it can't be here because of this 2. So this is like a 6 or a 7? I don't think that helps. 7, 6, 1, 4, 3. Was there a reason that I'm not seeing that one of those won't work? If this is 7, this is 7, then we would have a 7 here. If this is a 4, I think that's all fine and dandy. So 1 puts a 1 down here. There's something I'm not seeing again. What am I not seeing? 9. Oh, this is a 9. That's what I'm not seeing. We can't put a 9 right there, so this is a 9. And that's going to be huge. Okay, so theoretically, we have a bunch of options here. This can't be a 1, 2, 3, or 4, or an 8. Okay, so this is literally just a 6. Okay, that makes it easy. 6 must go with 3. You can't double 6. So this is just going to be like this. We have a 3, 6 here, so this is a 4, which makes this a 7, 6 like this. These can't be 6, this can't be 3, or 7, this is 4, 3. This 7 is going to look down. This is 2, 4, 4 goes down there. Whoops, that was supposed to be the 2. This is an 8, which is going to resolve the rest of the puzzle, or some of the rest of the puzzle, but everything is resolved now. There we go. Very nice. Yeah, about 2 out of 5 difficulty. Very fun. Christmassy. Not Christmassy, but it is on Christmas, so it's, I guess, Christmassy by default. Yeah, thank you very much for that puzzle, Ambrose. I did enjoy that quite a bit. And thank you all for watching.